In this video, we're going to look at a whole bunch of examples. I don't normally spend a lot of time in these videos going over examples because there are so many other people creating really good content of going through examples on YouTube, but I figured I would just take a look at a couple. We've seen how the product and quotient rule and chain rule are going to work, but now let's take a look at them all at once. So I'm going to encourage you at the beginning to just pause along the way. I'll try and go relatively slowly through here, setting things up, explaining where product, quotient, and chain rules are showing up. And along the way, if you think you've got an idea of where we're at, just pause it and see if you can finish things out, or at least get a couple of steps forward on your own. That's going to be really critical. Even if you end up pausing this video for 15, 20, 30 minutes at a time while you work through something that you think you've got an inkling about, that productive struggle is really helpful. Okay, so I'm going to start trying to identify what rules we have going on. I'm looking for products of functions, quotients of functions, and composition of functions. I'm going to notice right off the bat that we've got composition. All of this stuff being raised to an exponent, classic chain rule. But also notice the stuff that's being raised to an exponent is a quotient of things, meaning when we differentiate the inside part here, while we're doing the chain rule, we will have to use the quotient rule. So there's going to be lots of stuff going on. What I'm going to do is write u equals 5x squared over 3x squared plus 2. That's my chain rule substitution that we've got. So I'm really looking at the derivative of u cubed here with regard to x. The chain rule says I'm going to differentiate that with regard to u, and then I need to find du over dx, or we can say that's the derivative of 5x squared over 3x squared plus 2. That's where our quotient rule is coming in. If you feel like you can work through this on your own, pause this video and go for it, but I'm going to start setting up my quotient rule. I know this part's going to be 3u squared, but over here, I'll call these a and b because I'm already using u. So a, my numerator, is 5x squared, and b, my denominator, is 3x squared plus 2. A prime, then, this is really dA over dx. That's 10x. And b prime, that's really 6x. Cool. Now, this derivative is going to be b times a prime, or I'll say 10x times 3x squared plus 2 minus a times b prime, that's 5x squared times 6x, all over b squared, 3x squared plus 2 squared. That's the thing that I'm going to put in place of this. So let me write this out now. This is 3 times u squared times this big blue fraction, 10x times 3x squared plus 2 minus 5x squared times 6x all over 3x squared plus 2 squared. Whew. All right, u, though, is this big fraction, so let's start doing this. 3 times this big fraction squared, 5x squared over 3x squared plus 2 squared, times, I'm going to start multiplying things out. This is 30x cubed plus 20x minus 30x cubed. Oops, I wrote 3x cubed. All over 3x squared plus 2 squared. I don't know if I want to multiply that out or not. I'll leave it like this for now. I can always multiply that quickly later on. All right, this is good news so far because I've got that this 30x cubed minus 30x cubed is going to be 0, right? So now what I need to do is square the numerator and denominator here. So that's going to give me 3 times 25x to the 4. That's 5 squared times x squared squared over 3x squared plus 2 squared times 20x over 3x squared plus 2 squared. that gives me 3 times 25 times 20, x to the 5th, over 3x squared plus 2 to the 4th. Let's see, what's 3 times 25 times 20? That's 75 times 20. 75 times 2 is 150. Multiply that by another 10, and that's 1,500 x to the 4 over 3x squared plus 2 to the 4th. That is my derivative. Ugly, right? We had a quotient rule inside of this chain rule, and then along the way, just a ton of arithmetic and algebra. Double check my work in here because I am notoriously bad at arithmetic and algebra. Make sure that that stuff looks okay. But that's a pretty decent sized example that we have. Whew, without stopping too much, here's another one. Let's do this. So again, take a look for products of functions, quotients of functions, and compositions of functions, and see what you can find here. I'm noticing a couple of things. We've got this x squared plus 1 underneath my square root function, classic chain rule. And then also notice that we're multiplying these pieces together. X squared times the square root function. So right off the bat, I can see there's going to be a product rule going on. So I'm going to label this A as x squared, and I'll label B as, I'm going to call it x squared plus 1 raised to the half. That's a really ugly 1. Let's fix that. X squared plus 1 raised to the half. A prime won't be bad, but for B prime, I've already got it in my head that there's some chain rule going on here, right? So maybe I'll label this thing as U equals x squared plus 1. All right, if you think you're comfortable with going on with this, see if you can give this a shot. Fill out the rest of the pieces. A prime isn't too bad. B prime, you'll have to use the chain rule to find. And then you can do your product rule combining all these parts. I'll go ahead and do this. This is 2x, that one I know. All right, so now we've got this derivative of u, or derivative with regard to u, sorry, of u to the half times the derivative of u with regard to x. All right, so that's half u to the negative half times 2x, but u is really x squared plus 1, so this is 1 over x squared plus 1 raised to the half times 2x. Oh, I forgot my 2 in the denominator. There we go. So this is really x over the square root of x plus 1. Whew. That's b prime. Now we can go ahead and do the product rule that says this is going to be a times b prime plus a prime times b, or however you call that, right? We'll multiply those things together. We'll multiply these things together. Let's see how this goes. A times b prime is x squared times this fraction, so that's going to be x cubed over the square root of x squared plus 1 plus 2x times the square root of x squared plus 1. We could leave it like this, or what you could do is say, well, let's see if we can combine these by multiplying by a common denominator. So let's get a common denominator of x squared plus 1 here. So I'll multiply it on the top and the bottom. But notice when I multiply that, I'm going to end up getting rid of that x squared plus 1. Getting rid of that square root. So this is x cubed plus 2x times x squared plus 1 all over the square root of x squared plus 1. Or we could say that's x cubed plus 2x cubed. Call that 3x cubed plus 2x. That's doing my distributive property here. All over the square root of x squared plus 1. All right, so again, chain rule, product rule working together, and then a bunch of algebra and arithmetic to get through. Not always super easy. Hopefully that's helpful. Oh boy. Oh boy. Let's see what we can do here. Obviously, we've got this quotient rule, right? Those ones are easy to see. Big old fraction bar cutting this thing in half. But notice right here, we also have a product of functions. So if we set up u being x squared e to the x plus 1 and v being x squared, then to find u prime, we're going to need to do a product rule on this thing. V prime is going to be easy, right? The derivative of x squared is just 2x. But hopefully we can see that we're going to have to do a product rule here. Maybe I'll call a x squared and b e to the x, and we'll find a prime and b prime, put those things together, and whatever we get there, that's what we're going to have for u prime. So if you feel like you can finish this thing out, pause the video, give it a shot, and then catch up later. All right, for the rest of us then, let's see what we can do. The derivative of x squared, we already know that that's going to be 2x, and the derivative of e to the x is itself, so we're good to go there. Notice that the plus 1 we don't have to worry about. It's just going to be 0 for our derivative. So now we've got 2x e to the x plus x squared e to the x. Now we'll do v times u prime, x squared times 2x e to the x plus x squared e to the x, minus u times v prime, 2x times x squared e to the x plus 1, all over v squared. All right, so we're going to do some distributive property on this to get one big denominator. So that's going to be 2x cubed e to the x plus x to the fourth e to the x minus 2x cubed e to the x minus 2x all over x to the fourth. All right, notice this term and this term are going to be 0. So we can call this x to the fourth e to the x minus 2x over x to the fourth. Or notice there's a common factor of x on that. Call it x cubed e to the x minus 2 over x cubed. Whew. That's our derivative. All right, so product rule inside of a quotient rule because it was in that numerator when we were finding the derivative there. So that was a little bit tricky. All right, let's move on to the next example. Wait a second. Are these the same example? Is there a mistake here? No, not a mistake. Let me show you an easier way of doing this. I like these upside down triangle shapes. I think they're really nice. What we could notice is that we can split this fraction up. This is going to save us a lot of headache. Let's split this up. We'll split the numerator up into 2 terms over the common denominator. This is how we add fractions, right? Common denominators add the numerator. All right, well, let's just reduce that first fraction. This is really just the derivative of e to the x plus, can I rewrite this? Let's call it x to the negative 2. Oh boy, that does not look hard. E to the x is the derivative of itself. The derivative of x to the negative 2 will be minus 2x to the negative 3. This is really e to the x minus 2 over x cubed. But wait a second, that's different than what we had, right? Not really. Can we split this thing up? That is x cubed e to the x over x cubed minus 2 over x cubed. Hopefully we can see those things are going to cancel out, and this is really e to the x minus 2 over x cubed. I would bet that we all are going to have a nicer time doing it this second way. When you see these upside down triangle shaped things, split those fractions up, see if we can reduce some fractions and make them a little bit easier on ourselves. Don't feel like you have to slog through this product quotient rule combination, although it's something that we can do. All right, let's try this one. Oh boy, there's a lot going on here. I'm going to make these parentheses on the outside extra big, just so we can really see what's happening here. This is sine of 2x plus 1 times 3x minus 5. So hopefully we can see there's a composition here because all this stuff is on the inside of our sine function. And we have a product rule along the way. So we'll set up u for our composition. We're going to call it 2x plus 1 times 3x minus 5. And now what we'll do is we're going to look at the derivative with regard to u of sine of u. And then we'll multiply that by the derivative of u with regard to x. But notice that when we do this part, we're going to have to do a product rule. So we'll say a is equal to 2x plus 1, b is equal to 3x minus 5. Find a prime, find b prime. Do the product rule. That is going to be du over dx. If you want to pause this and see if you can finish this stuff out, go ahead and try it. Otherwise, let's keep going. Okay, a prime is 2, b prime is 3. That part's not hard. And now for the product rule, we don't really have to worry about order here, right? So this is cosine of u times, I'm going to write all this stuff out. That's 3 times 2x plus 1 plus 2 times 3x minus 5, right? Cosine of u is really going to be cosine of 2x plus 1 times 3x minus 5 times 6x plus 3 plus 6x minus 10. Or we can write this as cosine of 2x plus 1, 3x minus 5 times 12x, right? These 6x and 6x can go together. And then we also have 3 minus 10. So we'll call that 12x minus 7. There we go. That'll work out. So that is our derivative here. Again, product rule inside of that composition. So keep an eye out for that. Wait a second. Another typo? No, not a typo. We're going to do this example again. We'll just take a look at something real quick. Notice that for this stuff, you can just multiply that out. We're not going to really need to do the product rule on that. That is really 6x squared plus 3x minus 10x minus 5. Or 6x squared, and then 3x minus 10x is negative 7x. So what we'll really do is say this is the derivative of sine of 6x squared minus 7x. And now this is a pretty straight chain rule problem. U is equal to 6x squared minus 7x. So we do the derivative with regard to u of sine of u times du over dx. Oops, I forgot my 5. There we go. So let me put that in here. Give myself a little bit extra space. I got a little ahead of myself. All right. Now we've got cosine of u, just like before, multiplied by the derivative of u is really easy to see now. It's just going to be 12x minus 7. And so we have cosine of 6x squared minus 7x minus 5 times 12x minus 7. And notice that that's the same thing that we had here if we multiplied these two things out. Exact same answer. Cool. So keep an eye on that stuff. If you can multiply things without having to do the product rule, feel free to do it. All right, for this one, we could multiply everything out, just like I was saying earlier. We could multiply 3x plus 1 times 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 2x minus 1 times 2x minus 1 times 2x minus 1. I don't know about you. I don't want to do that. That sounds awful. So, yes, we could use the same trick that we used here and just say, yeah, multiply all that out. Then we don't have to worry about product rule and stuff because it's just going to be a polynomial, right? No big deal. Yeah, but this polynomial is going to be god-awful. So what we'll do is we'll do this product rule. We'll say u is equal to 3x plus 1 raised to the 6th power. V is equal to 2x minus 1 cubed. And we'll notice the chain rule goes really easily for both of these, right? I'll let you figure that part out. I'll give you an answer in a little bit, but pause the video, do the chain rule on these, and then start putting your product rule together, and this is going to look pretty nice without us having to slog through all of that awful polynomial multiplication. Pause the video, see if you can finish this one out. All right, hopefully we see this. The derivative of u is really just going to be 6 times 3x plus 1 to the 5th times 3. That's the derivative of the inside. Or really we can say 18 times 3x plus 1 to the 5th. Similarly, v prime is going to be 3 times 2x minus 1 squared times 2, the derivative of the inside part. So we'll call that 6 times 2x minus 1 squared. So those are our derivatives of u and v. Now what we can do is multiply these things together, and what we get is 18 times 3x plus 1 to the 5th, whoops, there we go, times 2x minus 1 cubed plus 6 times 3x plus 1 to the 6th times 2x minus 1 squared. If you want, you can do a whole bunch of factoring here. You can pull out a common factor of 6 times 3x plus 1 to the 5th times 2x minus 1 squared. And what you're left with is 3 times 2x minus 1 plus 3x plus 1. You don't have to do this factoring, but sometimes it's nice to see. 3x plus 1 to the 5th, 2x minus 1 squared. And now this is 6x minus 3 plus 3x. So that's 6x plus 3x. That's 9x. We have a minus 3 plus 1, so that's minus 2. So we can just write it this way. If you left it in this form, I'm not going to worry too much about it, but this looks pretty good too. And notice that now we don't have to slog through all of that polynomial multiplication to get there. All right, that's a couple of examples of just combining product, quotient, and chain rule. Hopefully you'll get used to doing this. It's not so bad, but they can be a little bit annoying. Get some practice on identifying when you're using what rules, and hopefully that'll be really helpful as we move on. In our next video, we're going to start moving on to just different ways of thinking about differentiation as a process. So we'll think about implicit differentiation. That's what's coming up next.